Greetings Dean Low, this is done by Natalie, Belle and Jingxiang.
Two very common reactants in hot packs are calcium chloride and water. The temperature of hot pack can reach 90 degrees Celsius. In this video, we'll illustrate and explain how hot packs work. This is the 3D structure of calcium chloride solid. For increased clarity, we'll be using the 2D structure to show the interactions happening at a particular level.
A heat pack contains water and a separate compartment of solid calcium chloride. Water molecules have a simple covalent structure, with one oxygen atom covalently bonded to two hydrogen atoms. Since oxygen is more electronegative than hydrogen, oxygen atoms are partially negative and hydrogen atoms are partially positive. Hydrogen bonds are formed between water molecules. When the user squeezes the pack, the barrier ruptures and the contents of the compartments mix. Water molecules are attracted to ions in the giant ionic lattice structure. The partially positively charged hydrogen atoms are attracted towards the chlorine ions, while the partially negatively charged oxygen atoms are attracted towards the calcium ions. Hydrogen bonds between water molecules are being overcome. This process is endothermic. Ion-dipole interactions between water molecules and ions in the ionic compound are forming. This process releases energy and is exothermic.
When the energy released from the formation of ion-dipole interactions is sufficient to overcome the electrostatic attraction between calcium ions and chloride ions, the ions are removed from the crystal lattice and the giant ionic lattice structure starts to break down. This process takes in energy. The calcium chloride begins dissolving in the water. When all the ions are completely surrounded by the water molecules, calcium chloride is said to have dissolved. Water molecules form a hydration cage around the cations and anions respectively. The hydration number of Ca2+ and Cl- is 6 as represented above. The equation of the reaction is as shown above. Energy taken in to overcome the electrostatic attraction between calcium ions and chloride ions is less than the energy given out to form the ion-dipole interactions between water molecules and ions in the ionic compound. The enthalpy change of this reaction is negative 81.3 kJ per mole. Therefore, the dissolving of calcium chloride in water is exothermic and releases heat. This is how hot packs work.